Okay, so everyone, this meeting is being recorded. Hi everyone, welcome to the DSC talk on GitHub Actions. My name is Kristie Tom, and before we begin, if you haven't already forked following repo, do so. I'll give us a couple seconds to fork this repo. That's only if you want to follow along. If you just want to watch, that's okay too. So I'll give that a few seconds. So yeah, a prerequisite to this event is a basic understanding of GitHub. So I'll just wait a few more seconds in case folks want to fork it and follow along. So as I was saying, my name is Kristie, and I'm giving this talk of GitHub Actions basically from my experience of working in large corporations with and without GitHub Actions. So over the summer, I did an internship at Google where I worked on open source software, as all first time interns had to do because of COVID. And I developed GitHub automation software that supported GitHub Actions. So I worked with GitHub Actions a fair bit over the summer, but in all of those repositories used GitHub Actions, and all of my other internships didn't use GitHub Actions. And from my experience, in conclusion, GitHub Actions makes your life better. The TLDR for why is that it allows you to automate things that so that you don't have to do them. And not only that, it is more consistent. That let's say you have like a checklist of things to do. Sometimes you might forget one. You're a busy person. I get it. So that's the first reason, is that it allows you to automate things. And then the second thing is that I think because it's a new field, this kind of level of repo automation, it's an easy way to stand out and kind of show that extra quality and care for your code. And it allows, I think, your code to be more consistent at a higher quality. So that's the TLDR. Stay tuned for more details. The agenda today is as follows. First, we're going to talk about life as a developer. Then we're going to talk about GitHub Actions, what they are, why you should use them. Then we're going to do a two-part demo. One where we're just going to do like a basic, just follow along with me. We're going to do something kind of fun and toyish, and then we're going to do a more complicated one with race conditions and parallel computing. So it's a little advanced if you're not familiar with threads and stuff, but hopefully it will be fun and you'll get a little gist of something anyway. And then last but not least, we're going to talk about building GitHub Actions, which I think is going to be an exciting growing field, especially like as AI technologies mature more and give more intelligent software pieces. So let's talk about that in a little bit. So first, life as a developer. Before my first internship, I thought that I'd be spending most of my days coding in a black terminal with green text, maybe coding in Vim, maybe writing C all day. That turned out to not be the case whatsoever. And when you go to the tech industry, if you're not familiar, sorry, when you do a tech job and you're working in a collaborative team, you actually spend a fair bit of your time working with other people, as well as maintaining a certain quality of your repository. So this includes like tracking bugs or features, working with your team members to make sure that they're understanding things, that you're understanding things. Then there's deploying your software, there's documenting it. And then what I'm going to emphasize on throughout this presentation are pull requests. And you can go back literally on the same pull request 20 times. So if you're not familiar, let's talk about and review what pull requests are. So it's a way to basically take your local copy of code and try and merge that into a more official copy. So to take another copy and that's not official and try and merge it into a more official copy. For example, it doesn't have to be that hierarchy, but basically you're taking one code, applying it to another. And this can't be done just or this usually isn't done without any kind of review process. For example, if I wanted to code something, it's more than likely that a peer of mine will have to look at my code and they'll review it and they'll tell me if it's good enough, or if there's, sorry, that sounded harsh. They'll tell me if they have any suggestions, and then they will tell me what they are. I'll fix them. And this process can actually go back and forth, as I said on the previous slide, like 20 times. I know a friend who had a PR open for a month and that he was working on that full time. There have been PRs with like 50 comments on them of things to change for like 200 lines. Like, these PR processes can be quite lengthy and taxing. And in my experience, towards the end of one of my internships, I spent 3 hours a day reviewing other people's PRs, not even doing my own work, literally just reviewing people's PRs. And let me tell you, it gets pretty tiring after a while, taxing. And what you start to notice when you review a lot of PRs is that not all of the things that you're telling that the person needs to change their code, some of that stuff can be automated. Like, you don't need a person to tell someone that they didn't lint. You don't need a person to tell someone that they're missing a license header. So for those of you who are unfamiliar, when you work in a large enterprise corporation, sometimes what they'll want at the top of each file is something called a license header, which is saying that so-and-so company owns the rights to this file. And it's mandatory that all the files have them. So guess what? It's either going to be the reviewer telling the reviewer keeping an eye out for this, or the coder, or best of all, it could be a bot. So why not automate that? Less work for us. So that's where GitHub Actions comes in. So we talked about pull requests, what they are. Any questions so far? Okay, no, so we're good. So yeah, pull requests is one of my favorite uses for GitHub Actions. But the most, I guess, trivial use case for GitHub Actions, which I think everyone, if you have code on GitHub, I think you're going to use this eventually, is unit tests. So yes, there's things like Circle CI, there's Travis, there's Jenkins, and they're all great. And if you already have that set up for your repo, keep it that way, no need to change. But if you are setting something up for the first time, you should try to keep it in-house, or I would recommend keeping it in-house. You don't have to set up another account. It's super simple. It's pretty much usually copy and paste for most use cases, or for a lot of use cases. And also, there's something called issues. So if you're not familiar, like, there's a tab on GitHub called issues. So I can quickly switch tabs and show you. There's a tab called issues on your GitHub repo, where you can file bugs or feature requests. And sometimes imagine the following scenario. Let's say you're responsible for this repo, and then someone files a bug. You have no clue what they're saying. You ask for clarification, and then they don't respond for 1 year. Are you going to keep that issue open forever? Is that bug report going to stay in your repo forever? No, what you're going to have to do is close it. So either you can do it, or you can get a bot to automatically sort through things in a year and close things automatically. So it saves a lot of time. Now you don't have to click through all the issues and read all of the comments and see what's going on. So yeah. Then there's building, versioning, publishing, and deploying their project. So I think that these are really useful too, as well. So for example, with versioning and publishing, you can also set it up so that not every commit gets automatically deployed. This just a little FYI in case anyone's interested. You can actually base it on something like a commit message. So like based on keywords in your commit message, you can deploy it to AWS, for example, and not every commit gets redeployed. For example, like if you just have like a little like comment fix, you don't need to redeploy it. And you can adjust the keywords to do so. And last but not least, documentation, which is not, I think, pretty objectively not very fun, but absolutely necessary as well, especially when you work on open source. You're going to want to have a file called release notes where you detail the difference between every single commit, like what changes there were. And you can get a bot to do this, like you don't have to. Less typos, less work, everyone wins. And then also you can do documentation validation. So as we'll see in the example, you can do something called broken link checking. So this is really useful if you have a repository with links, and then let's say when your link goes down, you're going to want to know if your document is still useful to people or has bugs like that. And there's so many more things you can do, like as we'll see soon, as we talk into more of the architecture of GitHub Actions, but basically it's pretty much limitless. And if I didn't list enough for you, you can go to the following URLs to get to your own GitHub Actions. So the link above, the first one is github.com/actions/starter workflows. You can literally copy and paste these into your repository. And that's, and then the action will automatically be there, like pre-configured, and it will just work. Or you can go to the marketplace and use it that way as well. Granted, you might have to tweak a few things if you want, but it's pretty cookie cutter. So how do GitHub Actions work though? So it's super easy to use, as I've been saying. You basically add to your repository a recipe in the form of a YAML file. So that stands for yet another markup language. And this recipe contains a list of what jobs and tasks it should perform, and also when it should perform them. So GitHub will then take your recipe and automatically run your jobs based on the when. So specifically, you'll create a directory called .github/workflows, and you'll have this YAML file there. So anything, any name, and then .yml or .yaml should do the trick. And the when is also specifically an event. So this includes cron jobs, and these are scheduled events. For example, a task that repeats every 15 minutes, the same task as a cron job, or 20 minutes. It just has to be repeating task. Webhooks, GitHub webhook events. These are just specific GitHub defined events, like let's say you open a PR, let's say you open an issue, or you close an issue, you close a PR. Those are all GitHub events, and you can check their website for a full list of their events. Click on that link there. This event hyperlink, or you can also trigger a manual event. And in this YAML file, you can either specify a GitHub action. So an action is a portable unit of code that runs a series of steps. It sounds very, I guess, arbitrary right now, but we'll see in the example what that is. Or you can actually specify shell commands. So that's really powerful. Like you can do like echo hello world and that kind of stuff in the YAML file. You can specify shell commands. And what will happen is that your action will run on a fresh virtual instance. So either on a VM or a container. And this is just more for your information if you're creating them later on. And just a little bonus information is that how this kind of works is that your Git, if you use like if you allow GitHub to run your things automatically, of course you can to run your GitHub Actions. If you allow GitHub to automatically handle that for you, what's going to happen is that GitHub has a server with software on it called runners, or it's a server that has a type of software on it, and that's called a runner. And these runners will listen for jobs in your repo, and then it will execute them exactly as instructed based on this recipe, and then it will return the job results back to GitHub. So did this job pass? Did this job fail? And it's basically the idea of like a pass-fail thing or other tasks. So let's see what, in terms of pull requests, what do jobs look like? So what you can do, and this is actually a really handy use for GitHub Actions, is that you can enforce that your jobs have to pass in order for a pull request to get validated. So this is called a branch protection rule, and this is only for public repositories or upgraded accounts. So this is such as like enterprise accounts. So if you have a private one, sorry, there's a question. Can you run actions on custom runners or servers, or are they only provisioned by GitHub? Oh, yeah, good question. So both. I don't know how to set up the to set up your own runner, and I think for most cases, like it's just easier to use GitHub's, because then you don't have to set up anything. It's pretty magic, as we'll see, but also not magic. So back to this pull request example. Yeah, so jobs are then called checks. So checks, you can consider jobs and checks kind of synonymously. And basically, if your job, in this example, if any of your jobs fail, so like let's say one of your jobs is running unit tests. If that job fails, then you can't merge your code in. And that's pretty good because you don't want your unit tests to fail per se and then merge it in, unless there's a really good reason. But in most cases, I'm guessing if it fails unit tests, you shouldn't merge it in. So that's really good that GitHub Actions can do that in GitHub as well. Any questions? Okay, good. But here's a question for you all. Oh, okay, so there's a, yeah, so in my co-op, we had the actions run on a Jenkins cluster set up with the webhook. Yeah, yep. So I mentioned about using GitHub Actions, setting one of the jobs as a unit test. So does anyone have an idea, like, let's say you have a unit test and you run it and it passes, and then without changing any code, you rerun it and then it fails, and then it passes and then it fails. Why would that happen? Like if you're not editing that code, if you're not editing the source code, why would the tests inconsistently pass or fail? Any ideas? I'll give it another 10 seconds. So that's someone said, are the tests broken? That's a good point. So these are actually called flaky tests, which means that the tests are not necessarily good. So you could say, yeah, they're broken, but basically the tests aren't consistent, and that has to do with race conditions. So I don't know if broken is the best word, but basically what you can think of, so there's two types of race conditions that can happen with your tests. Either, but overall, they follow this idea. Let's say we have two streams of events, and each event one has a series of steps, event two has a series of steps. So let's say that they can execute in any type of permutation. So let's say event one can execute fully, and then event two can execute fully, but sometimes they might be interleaved. So that's kind of also how your unit tests can run. So either some unit tests can run or they can interleave, and your test should be designed such that tests do not depend on each other, because sometimes that dependency might be met, sometimes that might not be, but also your code can have those dependency errors too, like not just the tests. So therefore, let's say you run your tests and they pass, and then you run them and they fail. Or let's say in the previous example, you can only, our flaky tests only concern when writing multi-threaded applications. Sorry, there's a question in the chat. No, so so there's two types of flaky tests. One is when there's a multi-threaded application or multi-processed. So yeah, multi-threading. But also tests don't always run sequentially. So like in a lot of testing libraries I've worked with, I think all of them, tests don't run consistently. Like even though they might look linear in your tests, or you might expect a certain file to run before another, they're actually ran like in any random order, and they're designed to be like that because your tests should not depend on each other. So tests can fail, but if a test fails and you have a multi-threaded application, how do you know what it is per se, right? So you need to know if your code is correct. And if it fails, and you're okay with your test failing, what's the point of writing the test, right? So what I've seen in industry is that when a test fails, so let's say in the previous slide, we have that you require all tests to pass, all jobs to pass in order to merge. So if your unit test fails, someone will just keep, and you'll get an X when it fails. Someone will just keep rerunning it, like maybe even 6 times until it passes. And then you as the reviewer is going to come along and see that green check mark and think, oh, okay, tests work. Sure, tests look good to me. And then turns out, no, they don't actually work. And this is bad for the other reasons. Sorry, what I'm saying, by the way, is a little contentious, and some people are okay with this behavior. As you can see in this link, the war on flaky tests never ends. But if you, the argument is that if you are writing a test, and let's say your test takes 30 minutes, if you're rerunning it and it takes like, or even like 5 minutes, if you have to rerun it several times, you're wasting quite a bit of time. And this is stuff that I've seen and heard of in the industry. And I think that GitHub Actions can easily help test for these things so that when you, as a reviewer, are looking at a PR, you don't just see a green check mark because, right, that's just for a single unit test and whether that passed or failed. But what you can do is run like the same test over and over again, and that can easily be done in GitHub Actions, and I will show you that in one of the demos. But first, we're going to do our kind of toy, dummy, fun example of a GitHub action. So as promised, I didn't lie. We're going to have a YAML file in the .github/workflows directory, and GitHub automatically picks up these files and runs them based on my when condition and my what. So my when, so I have this file called cats YAML, so that's the correct extension. And then what I have here is that I have the syntax on pull request. So for those of you who are unfamiliar with YAML, how it kind of works is that there's a key value hierarchy where, yeah, the green are the keys and then the blue is the value. So on pull request, for branches, for particular branches only that have pull requests on them, I'm specifying that to be main. So when there's a pull request to main branch, sorry, my lamp just shut off because it overheated. For the following, I want to run the following jobs based on my when. So what are my jobs? I have the job called send me cats, and it runs on Ubuntu latest. This is a required field specifying what OS to run on. And I think it supports Windows and Mac as well. But here I'm specifying Ubuntu latest. And then I'm going to run the following steps. And we actually here, we only have one step. That's great. It's called action cats. And what I want this GitHub action, what I want this job to do, sorry, is to comment on a pull request with a cat GIF. So how do I do that? It's actually quite simple. All I have to do is specify this to get that to work. Now, what does this, how does this work? So what you do, is you specify the action and then you specify the version. And this action, RUAIR, actually corresponds to someone's repository. So if there's a repository with an action YAML, as you can see, use this action, then it's a valid GitHub action. And you specify that. And what this repo software does is comment on my pull requests. It knows my repo already. And then it's going to comment on my pull request with the cat gif. So let's see it work. So I have a branch with some changes in it. And I'm going to create a pull request onto my main branch. So we can see that I just took my README file. I just added some text, called some changes, nothing fancy at all. And then I'm going to create a pull request onto my main branch. So I have changes and I'm just trying to merge them into my main. Create pull request. And we should see the cat gif. Yeah, so it's in the process of running. So eventually we should hopefully see it pop up. And lo and behold, it's a very adorable cat with a party hat. Okay, so that concludes the first demo. So FYI, in reality, you're probably not going to do something like just commenting cat gifs. What you can do, what I've seen in Google open source repositories is commenting on the code coverage. And every time, I think every time you commit, it recomments the code coverage of the recent test. So like you'd see like here code cov is 99% or maybe it's 0%, and then you make another comment and then it will, I think it comments the latest code cov. And that concludes the first demo. And now we're going to do our more interesting demo with race conditions, and we're also going to see the broken link. Yeah, sorry, my lamp unheated, so it's back on. So I have my repository here. So I'm going to show you the race condition. Actually, first I'm going to show you that I have a README with a non-broken link, which links to Google. And then I have a README with a broken link. So just keep that in mind, because we're going to test for, we're going to create a job that tests for broken links. So now let's go into that race conditions. This is a bit off topic of GitHub Actions, but I think GitHub Actions helps point out these issues. So as I mentioned earlier, imagine the same example where you have two events. Let's call it event 1 and event 2. And this is a very high level example if you're not familiar with threads, or non-technical example. But let's say event 1 has 10 steps, and it just says, I'm event 1. And then you have event 2 that has 10 steps, and it just says, I'm event 2. If you don't have any type of locking or anything with your threads, basically what can happen is, instead of it just being, or it could be just event 1, I'm event 1 10 times, and then I'm event 2 10 times, but it could also be any mixture of the two. But if your code mandates that event 1 must say I'm event 1 10 times before event 2 says anything, then if your test requires that, but in reality your code does whatever, then your tests aren't going to be consistent. So here I have a function called my main, where we call these two. So this is my event 1 that I was mentioning earlier. It just says I'm event 1. And if thread 2 ever executes, like during thread 1's execution, I'm going to say that thread 1 executes first is false. And then thread 2 just prints I'm thread 2. And then I'm going to run these two threads, and I'm going to return whether or not thread 1 executes first. So I'm returning whether or not we saw thread 1 10 times and then thread 2 10 times. And as I mentioned, if you have a test that only wants thread 1 before thread 2, then it's going to be a flaky test. So this is just an example. And I want to emphasize that you should not code with global variables without any locking. This is a particular case of, do not follow, but just for demonstration, we can see how flaky tests work. So I have this repository cloned on my local machine. And if I run PyTest, we're going to see that the test do not pass, because we see event 1 runs 3 times, then we see event 2. So we don't see 1 10 times and then 2 10 times. So if I run it several times, eventually it will pass. I think last time it took me like 10 times. Yeah. So it took me quite a bit of tries here, but actually some people I've seen do like 8 retries and then they'll merge it in. And the tests don't take half a second, they'll take like minutes. So it's very time consuming to rerun tests if you have flaky tests. And that's just to show you what would happen if you don't have a flaky test check. And then as a reviewer, you'll be like, oh, green check must work. But no, not really. So let's create that. Let's create that action. So what I'm going to do is I'm going to create a new branch called Flaky Test. I'm going to create a branch, and I'm editing just in the browser just because it's easier for demo purposes. I think it's more readable, but not something I actually do in industry. So I have this branch Flaky Test I'm on. I'm going to the GitHub Workflows directory. I'm going to go to this file I have, CI. The cats one was, the other cats file we saw was something from earlier in the previous demo. But what I want to do is I'm going to fill in this file with you guys, and hopefully there's no syntax errors, because then my stuff won't run. So I'm going to edit this file. First, I'm going to specify a branch. So actually, first thing I'm going to do is actually change this to pull request. And then I'm going to specify, as I mentioned, a branch. So branches name. So I'm going to be making a pull request to my main branch to trigger my flaky tests. So the next thing I want to do is actually fill in my flaky test. But let me go over the syntax again here. So as usual, after specifying your when, you're going to specify your what, which is your job. So here I have one job, which is called flaky tests, and you specify the environment that it runs on, and then you're going to specify the steps of your job. So the first thing that we want to do is call this action here, which downloads our code for us. So yeah, just by specifying this, just a few letters here, this automatically downloads our code for it, and we can do anything like literally cat to the file. We can write to the file and run tests on this file. So yeah, we download our repo source code. Then we're going to set up Python, but I'm actually going to change this to Python 3.8 because the version I showed you earlier in the terminal uses Python 3.8. So I'm just going to keep it consistent. And then I'm going to install dependencies. And then, yeah, just so that I have PyTest when in order to execute my tests. And now I'm going to specify the command to run PyTest repeatedly. So for bar in 100, do PyTest done. So I'm rerunning this PyTest 100 times. Now you might be thinking, oh, do I want to run my tests 100 times each time I make a pull request, or like do a commit to my pull request? Especially if your pull requests take like, especially if your tests take a few minutes. No, you don't want to do that. So what you can do instead is specify a cron job. So you can do something that's so that it doesn't bottleneck your PR that way. So let's do a cron, and that's with the following syntax. And this is using POSIX string syntax. The minimum time we can put is 5 minutes. 1, 2, 3, 4. Hopefully that's right. But the only issue with this is this only works on your default branch. So like you can't run it on your dev branches, only the GitHub default branch. So you can run, crons only on the default branch, which in my case is the main branch. By default, I think right now GitHub has master as the automatic default branch, as the default branch. So what do we have here? Oh, what does a cron job do? So good question. That runs a job repeatedly. For example, it's a cyclical event. Basically, let's say I want to run a job every 15 minutes. That's a cron job. And that job can be anything, literally anything. Like you could echo hello world every 15 minutes. You can read the state of a file every 15 minutes. You can read the state of a Kubernetes cluster every 15 minutes. That's what a cron does. Does that answer your question? Okay, perfect. So here I'm running a cron job every 5 minutes, and the cron job is my Flaky test job, which is running PyTest 100 times after setting it up. So I download the repo, set up Python, install dependencies. Now this may seem like a mouthful, but I actually copied and pasted this code entirely from like the templates. So I definitely would have made many more typos, but I actually copied and pasted this, and here it was just PyTest, but now I just added a for loop. So yeah, it's pretty cookie cutter. So that's also what makes it so easy. Cool. So now we're going to add another job, which is the linkinator, or the broken link checking job. And that's done in the following way. So first you specify the job name. So linkinator, let that be my new job name. And then as usual, you have to specify the runtime environment, runs on Ubuntu latest. And then you're going to perform the following steps. Uses actions checkout v2. I think that's spelled right. Yeah. So because I want to do a type of code search that requires scanning my source code, you have to download the repository, and that's done here using this action, which downloads your repo for you. And then I'm going to then call the action that's going to check for broken links. So it's going to scan the files and check for broken links. And that's done in the following way. Justin Beckwith. So this is someone's username, and this is their repository. Linkinator dash actions with, and I'm supplying parameters to this GitHub action. And that's it. So this syntax also you don't have to type out. His documentation literally has this also cookie cuttered. So even though I typed it out for you, you would literally just paste it in. But I thought that that wouldn't be so aesthetically pleasing. So here, if all the syntax is right and there's no spacing issues, we should have that when I make a pull request to my main branch, that I run the Flaky test and I do a broken link checker. So as we know, I do have Flaky tests though, and as we do know, my README does have that broken link. So we should see that 2 jobs fail. So when I create this commit, what I want to do is create a pull request, because that's my one condition. Create pull request. And I've also set it up such that my jobs need to pass in order for me to merge it. And there's the cat GIF. And the Flaky test check failed as expected because I have Flaky tests, and now we can't merge our code in because of this. And the Linkinator is taking more time than usual. Hopefully my internet hasn't cut out. Okay, there we go. So the Linkinator test also failed because I have broken links. And that concludes it for the demo. I again want to emphasize that the code I wrote of uncontrolled access to globals is not something you should do. If you use my name and have multiple threads and just access global variables, I will be very career destroyed. And that concludes it for the demo. We saw that you can test for Flaky tests. You can help protect your repo against Flaky tests using GitHub Actions, and you can also test for broken links. And the way to do that is just by pasting in someone's repository endpoint. So as we saw with the cats demo, like you literally just paste in this guy's repository and you specify the version. So super easy, and plus most of it is like copy paste anyway. What you can do is also build your own GitHub Actions. So this is a growing field, and GitHub Actions is pretty new. I would say the majority of my friends don't know about it, but it's actually so useful. And I was thankful at Google where they forced us to use it, if you will. No, well, not forced us, but so what you can do is scan files and check for errors, as we saw with the Linkinator, the GitHub action. And if you built your own, what you would do is you would scan files, whatever you're checking for. Let's say you're checking for bad variable names, or what I've seen more of a push of actually is like culturally sensitive or socially sensitive variable naming. And you could scan that. Maybe you need AI for that, not sure. And what you could do is if you spot anything you don't like in the code, you could cause that process to throw an error. And that's pretty much it for the logic of building a GitHub action that scans files and checks for errors. Alternatively, this is, I guess, more of my favorite ones because, well, I guess the last one too. So what you can do is automatically create a PR with a set of changes, or you can automatically comment suggestions. And if so a use case would be like the license header example, so that like you as a person don't have to paste in at the top. You don't even have to write a script to paste in the license headers. You got this bot to do it for you already. So that's an example of automatically commenting suggestions, and it will look like this. And there should be a button to just automatically commit it in here. And if you're concerned about a bulk of commits, what you can also do is squash your commits at the end. So yeah, you'll you'll commit all the suggestions. And if you're interested in doing this approach, I would recommend using the library code suggester, because you have the logic, first of all, to kind of generate what suggestions to make. Like, you need to know what text. So we see here, there's kind of this this text generation going on. But that just purely has to do with files and text files. What you, or other file types work as well too. But then you still have the hurdle of interacting with GitHub, and there's several edge cases and stuff. And if you don't want to go through that, I would really recommend using Code Suggester, which is a library I wrote while at Google doing my internship over the summer. So yeah, absolutely check that out if you're interested. And I think that this is a growing field, especially as software becomes more intelligent with AI. Maybe there's we can get these bots to do more work for us. And if you don't need to use Code Suggester, to interact with GitHub, so like as we saw, this is actually from the cat GIF source code. What you're going to do is interact with the GitHub API this way in order to, for example, in order to create a comment, you're going to create, you're going to basically interact with their OctoKit library, which is a wrapper for the GitHub v3 API. So it's pretty much always following this syntax where you just have properties, and their docs are pretty extensive about that. And this is just a wrapper for the v3 API. So this is in JavaScript, and you should have your types by using this OctoKit wrapper. And there's other ways to do this, by the way. This is just one way, and the way that Code Suggester uses the GitHub API. So, and when you create your GitHub action, in order to publish your package, you don't really have to do anything except for have a YAML file at the root of your package. So as we saw, like in this cat demo, action YAML, that's what you need. So yeah, what you need is source code and action YAML. And then for anyone to use your code, they just specify your repository endpoint. So like your username /repo and like any versioning, and they pass you parameters. It's super simple. But I also want to emphasize one other thing. So here I have JavaScript as the example, but you can actually write GitHub actions in any language. You can even do like a bash script. And then you would do something called a Docker container action, where it spins up a Docker container and installs everything as you've set it to be. And yeah, if it's a bash script, it will run it. If it's in C, it should run it. But otherwise, if it's a JavaScript action, it doesn't use a Docker container action. It just runs it on the virtual machine itself in a fresh environment. And it's pretty simple. Sorry if this is a mouthful. If you didn't get the gist of, if you didn't understand most of that, that's okay. But basically, yeah, hopefully this provided a little bit more clarity on how to build GitHub Actions. And for more information, you can go to the following links to look at the docs. So the first three are just about what GitHub Actions are, the basics and the basic YAML syntax for using GitHub Actions, and some general architecture, which I think my general advice to people is to kind of understand the architecture. I think it's great to look at how other code works, how other software works, and that just helps you learn just through mirroring. Like if there's good practices in that software to, good architectural decisions, it doesn't hurt to know it, such that you can yourself design better code. And this is also the link to Code Suggester, which again, I wrote with my host. And also that's the link to the OctoKit library if you're going to write a JavaScript action. So not a Docker action, but a JavaScript action. And what can you do with GitHub Actions? Actually, recall that GitHub Actions can run shell commands, and actions can run in 2 types of fresh virtual environments, in a Docker container or on a VM directly. So literally anything. You can write to the file. You have like basically a file system to work with. So anything. But if you don't feel like writing GitHub Actions and building your own, use these starter workflow templates, which are pretty much copy and paste. And that's how I built this this tutorial, just by copy and pasting. Or visit the marketplace for more GitHub Actions. And that's it. If there are any questions, I will be sticking around for a few minutes. If anyone has any questions about GitHub Actions, Code Suggester, or just in general, feel free to chat. Thanks, everyone.